building and work together with our ASEAN member states to do a lot of activities. The next one is, of course, BMKG. It's the lead of ASEAN Earthquake Information Center, and the main roles and facilities, including the collaboration with the AHA Center, the disaster. For this one, I just want to mention about the high performance computing. This is considered as one of the most successful initiatives together with the EU. And the high performance computing has been done since 2 years ago. And this year we're going to do face-to-face activity. And we have 3 critical applications areas. The first one is life science, earth science, or urgent computing. And this year, at the end of the year, we're going to invite Mr. Jack Dongara, the 2021 Turing Award laureate. It's similar to the Nobel laureate in ICT. So Fugaku and Oak Ridge National Laboratories are considered as the 2 fastest HPC in the world. Another activity is the ASEAN Disaster Management and Emergency Responses. This is related to the Bandar Sri Begawan Declaration on the Strategic and Holistic Initiative to link ASEAN Emergencies and Disaster, ASEAN Shield. So we're planning to have the ASEAN Disaster Resolution platform. I'm sure this will be related to CORDEX activities as well. And then the ASEAN State of Climate Change report that we mentioned. And then the newest one is the ASEAN Climate Change Center that will be established soon. So the agreement is being signed at the end of the year. This center will be led by Brunei Darussalam. And the one that's still under development is the ASEAN strategy for carbon neutrality. And hopefully we can get endorsement of the net zero GHG emissions. I have 2 minutes. Okay, so some potential collaborations that maybe we can pursue is something related to the regional recovery, the ASEAN Comprehensive Recovery Framework, the ASEAN Post-2025 Vision, and for science and technology innovation is the ASEAN Plan of Actions on STI 2026-2035. Some potential collaborations is over here mentioned in the ASEAN State of Climate Change reports. So I think one of the example is the number 9, strengthen climate change impact projections and their downscaling. So what's next? I think we can do more discussion about this, and then maybe we can also explore on how we can collaborate with ASMC, with AEIC, and this one, the AWMC, is the new one that's proposed by Thailand, the ASEAN Weather Modification Center, and of course the ASEAN Center for Climate Change. I think that's all from me. I hope it can give some clear explanation a little bit about our initiatives in the region. Thank you so much.
Thank you, Dr. Nalita, for a really nice overview of ASEAN. May we have one question?
Thank you, Dr. Veni, and thank you for accepting our invitation to come here. And your presentation for giving an overview of what ASEAN is, what ASEAN does, I think it's very important for us, in this CORDEX Southeast Asia. For your information, CORDEX is not agenda of a particular country, not agenda of a particular university, but this is a top-down program going to start from World Meteorological Organization down into World Climate Research Program. And so it has a top-down agenda. I mean, top-down initiative actually. So ASEAN may have its own way of doing things, but with the right, meeting or discussion or exploring where to fit in and so on. I'm sure, I think there is opportunity for us to, okay, of course we cannot decide now, but if we can, start looking at each other and where we can look, I hope there will be a possible future collaboration, because as you can see already, some of the things that we are doing, basically serving the member countries, which I'm not really sure those kind of thing. It sounds like that's already been in your planning, or maybe already have. I'm not really sure. But my suggestion and my hope is that hopefully we can keep talking, and we're more than happy to collaborate with ASEAN in the future.
Thank you, Professor. I think we're always welcome any collaboration in the region, especially I saw a lot of data here already. Maybe it's just we need to discuss further on how to pursue that for the regional initiative. Thank you, Prof.
Oh, okay, thank you, Pani. I think one way to do, as Professor Tang mentioned, is that we must, we can maybe set up education team for ASEAN based on CORDEX data. That is one way to do it. I think we have to discuss after this what is the thing that we want to educate through ASEAN. I think what we made through IPCC is that CORDEX supply the data, and then right now public all over the world can see what is happening in the Southeast Asia through web of IPCC and through the web of CORDEX. This can be done as well to the ASEAN. I think you mentioned about the ASEAN Climate Change Center. I think that is maybe one of the products from us can be channeled through them, and then can be education for public. I think that is the way, one way I propose.
Thank you, Prof. Alvin. And actually, we're going to have a meeting soon, maybe next month with ASEAN Climate Change Center. So I will convey a message if you want also to meet with the Secretariat. Thank you.
Thank you. Thank you, Dr. Nalita.
Thank you.
So we move to next presentation from Mr. Siaswan from Malaysia, Narim. He's going to give us a presentation about the importance and needs of climate projection data for river basin research in Malaysia, please.
Hello everyone and good afternoon. My name is Muhammad Shazwan Faisal bin Muhammad, and I'm from the National Water Research Institute of Malaysia. Today I would like to give a presentation titled The Importance and Needs of Climate Change Projection Information in River Basin Research. And this is my outline, the introduction and why the climate change projection information is important, and number 3, needs from this cyclic project, and number 4, the conclusions and way forward. Okay, what is the river basin? We all know, right? River basin is an area of land from which all surface runoff flows through a sequence of streams, rivers, and possibly lakes into a single river mouth, estuary of data. And why river basin is important to our life? Because a river basin or rivers have been used as the source of our water for food, transport, electric hydropower, and a defensive barrier. And also for thousands of years, rivers also have been used for navigation. And what is the impacts of climate change to the river basin? For example, frequent droughts and shifting precipitation patterns will lower the water levels in rivers, lakes, and streams, thus leaving less water to dilute the pollutants. And higher temperature also could cause more frequent algal blooms and reduce dissolved oxygen levels, both of which can cause fish kills and do significant harm to ecosystem. And the climate change also could impact many aspects of river flows, including the magnitude of hydrological extremes and their timing within a year. Okay, why climate change projection information is important? Actually, there are needs to assess various future water resources availability, the stream flow characteristic, of the water-related hazard identification. We need to map the potential flood hotspot area. Need to also map the potential sediment disaster hotspot area. And we need to assess the water-related structure planning, integrity, and security. For example, the flood mitigation projects, sabo dam construction, and agriculture, irrigation, and etc. We also need to assess the river basin erosion and sediment plan and control, and also the riverbank erosion detection, mitigation, and control under the influence of climate change in future. Okay, and now I list several hydrological procedure or hydrological analysis usually involved in the river basin research and planning, such as the min and max or minimum flow analysis, the flood frequency analysis, or we call it FFA, the flood duration curve analysis, FDC, environmental flow analysis, or EFLOW, the probable maximum precipitation, PMP, probable maximum flood, PMF, and the rainfall intensity duration curve. Okay, I just share a very short case study. Titled Assessment of Impact of Climate Change on Stream Flow Characteristic in Sungai Muda Watershed using the soil and water assessment tools that have already been described by Dr. Tan yesterday. So in this So in this study, we just use the, at that time, we don't have climate projection, a latest climate projection data set, so that just make use of CIMIP-5 data sets that already been downscaled by the NASA group named NASA Earth Exchange Global Precipitation Projection, next GDTP, using the bias correction statistical, bias correction spatial disaggregation that have a resolution 0.25 degree under the RCP 4.5 and 8.5 scenario. But this dataset is intended for use in scientific research only, and use of this dataset for the other purpose, such as commercial application, need a consultation with the expert. Okay, we just use the 3 GCMs, which have a dry, quite dry and balanced, and wetter GCM. And in general, the projection suggests the Malaysia rainfall is likely to increase slightly by 5 to 10% in future. So from this assessment, we found that in future, under the RCP 8.5 scenario, the projected changes is around up to 38% during April and May, which is the April and May is the rainfall peak season in this watershed, while July to September is the dry season in this watershed. For the future minimum monthly flows, is expected decrease around up to 40% during the dry period. And during the flood season, the minimum flow is expected to increase up to 36% during the end of the century. We can look on during February and March also expected to decrease in the minimum monthly flow during the very dry season. Next, we carry out the flood frequency analysis. Beside the unit hydrograph method and rainfall runoff method, frequency analysis is one of the main techniques used to define the relationship between the magnitude of an event and the frequency with which that event is exceeded. Why FFA is important? Because FFA is used to determine the magnitude and frequency of floods that will occur in the project areas by engineers. So this is an example of the ensemble average from our assessment, the FFA analysis at the gauging station. So we can find that in future, at the end of the century, the increment is around up to 12% for the 100-year return period flood. For example, for the 100-year return period flood, the increase is around almost 200 meter cube per second. It's quite a lot of amount of water that will be increased in future. Okay, this is from the different assessment. I just want to show the impacts.
5 minutes. 5 minutes.
1 minute. Okay. I just want to share. We need hourly rainfall data to drive the hydrological model so that we can get the exactly projected amount. For example, this is the daily stream flow data compared to the hourly stream flow data. It buys around almost 150%. Okay. Okay, now I need to skip. There's several important hydrological procedures such as flow duration curve analysis, and then an environmental flow analysis, and probable maximum precipitation analysis, and rainfall IDF curve analysis, and probable maximum flood analysis. So I just listed our needs from this cyclic project, several crucial climatic variables such as precipitation, preferably hourly and daily, mean and max temperature, runoff, solar radiation, wind speed, relative humidity, and evaporation. And I also would like to request so that the climate projection data should be easily downloaded by the end user. Maybe this can provide easy drop-down menu for selecting variable, GCM, scenario, and climate epochs. And just by, we can key in the long-net input and then box region. Dataset should be attached together with user guideline and report article to be cited in the dataset. And users should be given also an option for bias corrected datasets, especially for the hydrological and watershed researchers. And my conclusion is that in order to build the resilience and adapt to future changes, it is important that decision makers have credible and up-to-date projection of the changes to hydrological extreme and also the indicator of the uncertainties. And long-term projections are especially needed to inform multi-million-dollar investment in water infrastructure, such as the reservoir and the flood defense schemes, which can take decades to implement and expected to last up for a century or more. And last, my suggestion is maybe the cyclic team encouraged to carry out the sea level rise projection and oceanography projection to produce the SST, ocean acidic level, salinity, and etc. for the Southeast Asia region. With all of that, thank you very much.
Thank you, Mr. Saswan. I'm quite sure that you have a lot of information to tell us, but the limit of time. You have any question? 1 or 2 questions, short question, please. Any question? No.
This last one is interesting. In fact, if CORDEX can go into this by coupling the atmospheric and regional ocean model, maybe we can address some of this. But we need money, Sazwan. We need funding. Please provide us funding to this. Vietnamese group is really experimenting with this. So once we know a little bit, this can be, expanded to other group as part of capacity building, right, Dr. Tan? So, yeah, I think this is important because, talking about coastal waters, which has a lot of vulnerability as well. Our blue carbons, a lot of other resources going to be impacted by climate change. But we cannot address only by looking at the atmospheric part, atmospheric model.
Thank you. Any other question? So I think we can proceed with the next presentation. The next presentation will be from Mr. Kadasa from BMKG. He will talk about the application of CORDEX data in hydrometeorological disaster prevention. Please, Mr. Kadasa.
Okay, good afternoon, everyone. Thank you for coming. Today I would like to present our research. This is my college. Before I will start the presentations, I would like to introduce myself. My name Kadarsa. I'm from BMKG, Indonesia Met Office, Center for Climate Change Information. This slide, I would like to introduce. This is the background of our research. The British Southeast Asia is a region highly exposed and vulnerable to the impacts of climate change. And impact of climate change is problem compounded by the low resilient and adaptive capacity of the mostly developing and the less developed countries in the region. IPCC RE5 has indicated the Southeast Asia has already been experiencing long-term change in climate with consequent impact. And the continued warming will likely affect the region more in the future. In Indonesia, we have the number of natural disaster in Indonesia is in 2021 is more than 5,000, and the number of natural disaster in Indonesia until October 2022 is more 3,000. So the number hydrometeorological disaster is 98% of the total number of natural disaster in Indonesia. Floods reach more 30% of Indonesia total natural disaster. This presentation focus on the flood disaster and the flood projection using CORDEX data. In this study, we use numerical experiment and observation data. From numerical experiment, we use hydrostatics, 5 km XCM, with downscale 3 global climate model like the MPI, HADCAM, and Earth, and we using XCM 4.7.1. For observation data, we use SIP precipitation dataset with resolution 5 km with period 1981 until 2005. And this is the RxCM4 setup, cumulus convection parameterizations from Emmanuel, ocean flood treatment from Jeng, and radiation CCSM. This is our area with the Java domain with resolution 5 km, because Java is the one of main island in Indonesia, and this is very important information about the floods, about flood projections. This is the rainfall projection about CORDEX 5 km, all of the 3 global climate model. The future precipitation trend is RCP 8.5 minus 707 millimeter per year. And in RCM 5 km projected future precipitation trend that was approximately 4.5 times steeper than RCM 25 km. And in this spatial distribution of rainfall from SIP in 1981 until to 2005, we can see in the high mountain areas there is a greater concentration of heavy rainfall, and RCM 5 km represent the observed spatial pattern quite well but overestimate. On this slide we can see the seasonal cycles of the rainfall, mountain precipitation in Java Islands. We can see the SIP, and we can compare the another RCM 5 km. SIP can capture the seasonal rainfall cycle in Java Island, wet season in December, January, February, and dry season in June, July, August. From the RCM or 3 experiment, we can see the rainfall cycle can usually forestate but quite comparable. In the most of the Java Island, southern coastline, coastal southern is so dry bias. Generally, Java Island's eastern region experience strong wet bias. However, during June, July, August, the western region is experiencing wet bias. We can see the special case in Hadgam Manuscript in September, October, November. There is more bias during September, October, November, followed by December, January, February. We have also another data from NRCM 5 kilometer. This is the cooperation with JICA, and we analysis for fraction index extreme. We have the precipitation total R50 and R100 to analysis the index extreme in Java Island. And there's also from index extreme, we use the CDD and CVD for analysis of the index extreme in Java Islands. And this is the step for flood projection. We use static map. We have the land use map, slope map, and soil texture map. And this is, we use index extreme, like PRCB total, monthly cumulative, daily average range, and we divide it into 5 classes, and also I think, and the last we use the criteria high, medium, low, and very low. This is the from land cover map, slope map, climate projection data. We combine into these equations. We combine the flood potential map, and the last is flood potential projection map. We can see the class like body water, swamp crab, secondary. We score 4, and scrub, plantations, airport, we score by 2.
We have 5
And
minutes. 5 minutes.
okay, this is the results of our research. This is for the change of floods potential in West Java. This is the preliminary results. This is a sample of December, January, and February. Is period 2022 and 2049. From this figure, we can see based on the process data climate projection in physical area, dominant flood potential area in the coastal lowland south in here, and also the potential for flooding is high in downstream of the Citarum watershed, Cimanuk watershed, and also Citandur and several other small watershed. This is conclusions. The RCM 5 kilometer from the global climate model, accurate but excessively simulate the observed spatial pattern in Java Island. Most of the Java Island southern coastal line is so dry bias. Generally, Java Island eastern region experience strong wet bias. However, during June, July, August, the western region experience wet bias. Headgum saw more dry biases during September, October, November, followed by December, January, February. And the last, based on the process data climate projection and physical area, dominant flood potential area in the coastal lowland south, and potential for flooding is higher downstream of the Citarum watershed, Cimanuk watershed, and Citanduy, and several other small watershed. I think that's all. Thank you very much.
Thank you, Mr. Kadasa. May I have 1 or 2 questions? Quick question. Any question? So in that case, thank you, Mr. Kadasa.
Okay, thank you very much.
Thank you. Let us move to the next presentation by our Philippines colleagues. Dr. Marcelino, he will give a presentation regarding the climate change information in the Philippines. Please.
Hello, good afternoon, and thank you very much, Mr. Chair, and to the organizing committee. My name is Mar Villafuerte, and I am from the PAG-ASA, or Philippine Atmospheric Geophysical and Astronomical Services Administration. And I'm tasked to discuss about the climate change information in the Philippines. Okay, so this is a quick timeline of or how we generated the climate change projections in the Philippines. So way back in 2011, we were able to provide our initial climate change projections, and this is actually mainly based on just a single model projection. And then in 2014 to 2017, we generated the RCP-based climate projections, and at that time, we were able to provide or utilize at least some regional climate models, not just one. And then in 2018, we were able to provide the updated climate change projections and also utilized observation data sets. And in 2021, just recently, in cooperation with Manila Observatory and Ateneo de Manila University, we were able to utilize the CORDEX Southeast Asia derived extreme indices and provide such kind of report. Okay, so in the 2018 report, these are mainly based on temperature, observed temperature and projections, as well as rainfall observations and projections. Similarly, we also provide some tropical cyclone related information, and quickly some sea level rise projections as well. And then in the 2021 report, these are mainly based on extreme temperature and rainfall indices. Okay, so, but before going to projections, of course, it is important for us to look at the observed data sets historically, because we need to convince our stakeholders, particularly policymakers, that whatever projections that we are going to deliver, at least we were able to observe that in the past. So at least in the Philippines, we were able to provide some information that in the past, 65 years at least, we were able to demonstrate based on observations that the temperature is actually increasing in the Philippines. It's about 0.1 degrees Celsius per decade. And earlier, I have also noticed from past presentations that the minimum temperature is actually more rapidly increasing as compared to maximum temperature, and that's also true based on observations in the Philippines. And some studies also have demonstrated that the number of hot days in our country are increasing in several locations. And also, we were also found out that in some areas, our rainfall are actually decreasing or in a drying trend. And in other locations, based on observations, rainfall are also increasing in other areas. Okay, and aside from that, there are studies that demonstrated the increasing frequency of extreme rainfall events. One of those studies is this. So the maximum 5-day rainfall are actually increasing in some areas, particularly those areas with triangles pointing upward. And of course, those increasing number of maximum 5-day rainfall can actually lead to flooding such as this. And in some areas, we also found that the length of dry spell is also increasing. So particularly during these seasons. And of course, that increase in the length of dry spell could of course lead to drought. Okay, and aside from that, we were also able to find some or detect some changes in tropical cyclones that affect the Philippines. So the black curves here shows the annual count of tropical cyclones that enter the Philippine area of responsibility. But if we looked at the more or the stronger type of tropical cyclones, particularly those that exceeds 170 kilometers per hour, then we noticed a significant or a slight increase in those occurrences, more particularly in the more recent decade. Okay, and another study based on historical data as well. One of my colleagues shows that the tropical cyclones are actually increasing more on the Visayas and Mindanao region, and particularly during the December, January, February season. Okay, and the main question that perhaps the climate change projections community would like to answer is whether those observed changes will continue in the future. And to be able for us to answer that question, we needed to utilize, again, regional climate models. And in this case, in the 2018 report, we utilized at least about 12 models. And in the 2021 report, together with Manila Observatory and Ateneo de Manila University, and we were able to use the CORDEX Southeast Asia simulations and come up with results with extreme rainfall and temperature indices. Okay. So basically, our projections tell us that in the future, the observed atmospheric warming in the Philippines will continue by about this rate. If we are going to assume the RCP 8.5, it's about 2.5 degrees Celsius to 4.1 degrees Celsius warmer by the end of 21st century. Okay. And more warming is actually expected not to occur during the hotter months, particularly the March, April, May in our country. And such increase in temperature might be accompanied by more intense tropical cyclones, as shown by these models, although we are expecting a slight decrease in tropical cyclone frequency, but those fewer tropical cyclones might probably be more stronger in the future. Okay, and based on our projections, we are actually advising our policymakers that particularly for rainfall, we are expecting, or we need to prepare not just for the wetter future, but also for drier future, based on the range of projections from the different models that we used. And another question perhaps that we need to convince the users of this information is whether the models that we are using are actually being able to capture the observed climate. And basically, we were able to show that after downscaling, these are the global climate models, and then after downscaling, it actually improved on how the annual cycle of temperature was of the Philippines was being modeled. And then, yeah, this Taylor diagram shows that after downscaling, the models are actually being improved. And the models are also able to capture the northeast monsoon season, particularly during December, January, February season. Here's the observation, as well as the southwest monsoon season during the June, July, August season, as shown on this right panel figure. Okay, and based on our projections, utilizing the CORDEX Southeast Asia data, then we were able to demonstrate that in the future, we are expecting that the warmest daytime temperature is projected to increase by about 3.7 degrees Celsius if we assume the RCP 8.5 scenario here, and that the fraction of hot days might also increase by about 75.8% if we assume the RCP 8.5 scenario by the end of 21st century. Okay, and such increases in temperature might also be accompanied by increases in maximum one-day rainfall, as shown here, particularly over Luzon and some parts of Mindanao area. And then the maximum 5-day rainfall, or RX 5-day, might also be increased in some areas, particularly here and here, but might also decrease in some locations. Okay, and such projected changes in temperature and rainfall are also translated into actionable plans, which are actually utilized by local government units in our country. And this kind of information were also provided on an online platform. And we also assisted various local government units in order for them to craft their plans. Okay. And these are also provided on the online platform, as I mentioned earlier. Here, GIS files can actually be downloaded, as well as those assessment tools, particularly the the CLIRAM, or the Climate Risk Analysis Matrix, which are being used by various local government units and academic institutions. And so far, these are how the climate projections that we provide on that online platform had been utilized by various organizations. That includes national government agencies, LGUs, academic research institutions, private companies, and other organizations, including local and international, particularly for academic and research purposes and for other plans. And mostly, it covers the entire country. So, yeah, in the future, we aim to provide or update that kind of information at a very high resolution, perhaps at least 1 kilometer across the country, and provide that information as well on our website. So that's all. Thank you very much for your kind attention.
Thank you. Any question for Dr. Marcelino? One or two quick questions, please.
A very simple question. Congratulations for the work done. I'm just wondering, in the platform, when you provide the data or to download data, do you also provide the observation station data, or is there any idea for sharing this?
Yeah, in that case, we only provided the data sets that we used, particularly the Aphrodite. So these are already on the seasonal means already. But we also have another platform wherein we users of observed climate data can actually access as well. So yeah, those are just a recent initiative in our country.
Any other question? Let's guess. Thank you, Dr. Marcelino.
Thank you very much.
Thank you very much. So we move to the next presentation by our Vietnamese colleagues, Mr. Trong Ba Kien. The application of CORDEX data in contribution to national climate change scenarios for Vietnam. Please.
Good afternoon, everyone. Thank you for inviting me here to introduce about the application CORDEX that in contribution to national climate change scenario for Vietnam 2020. My talk today is two main parts. First one, I would like to introduce about climate change scenario for Vietnam, and with the highlight on the contribution of the CORDEX data for the climate change scenario for Vietnam, the latest version in 2020. And the second one, proposed plan for climate change and sea level rise 2025 for Vietnam, and beyond the CMIP6. Here this slide shows the IMHAN and have implemented to have the Monterey the public. The first one 2009. The first one we are based on statistical downscaling, use the matrix again, and beyond the AR4 reports. The second one 2012. Also we are use a hybrid between the statistical downscaling and dynamical downscaling, with use for dynamical downscaling from the Brexit model from the UK. And the next one is 2016. We are purely use the dynamical downscaling with the collaboration between the CHIRO, HUH, and Norway and other. And the latest one, it's called 2020, but we Monterey 2001. This we are based on the dynamic downscaling and also use the bias correction with totally 26 RCM component, and we have get the data from the CORDEX This data set by the Professor Ngô Đức Thành and his team for Vietnam. And here for totally data for generate a climate change scenario for Vietnam. Officially, this 16 from the previous data, and 10 members this is from the CORDEX data. And exactly here we have been said by the Professor Thanh, 10 members from the CORDEX cyclic data for our latest climate change scenario for Vietnam. And here I would like to show very briefly about the verification of 10 members from the CORDEX cyclic for Vietnam. You can see this color is also for observation, and other for 10 members of the CORDEX data. You can see that's almost the model for temperature for the annual cycle is a little bit lower than the observation, but only the CORDEX C IPSL for REXM also simulate quite 4 or 5 degrees higher than the observation or in the summertime. Yeah. And here from the precipitation for 10 members from CORDEX, you can see that also the CORDEX IPSL also is not good, and other it could be suitable for project climate change in future for Vietnam. And here for yes, it's, the left one is temperature, the right one is precipitation. With the Taylor diagrams, you can see that here for temperature is okay, 10 member is okay, so correlation very high, can reach for annual, you can 0.8 or 0.9, 0.9, and very small errors. But for precipitation as a story, you can see that here for IPSL, GCM data driven, it means zero scale, and also this one is for HCM here also little bit not good, and other we can accept available for with the correlation about 0.5, and we use 10 member for the climate change for Vietnam. Here for this is for method and data, we also in the Vietnam climate change scenario for 2020. We only provide 2 RCP RCP 8.5 and RCP 4.5 is the medium scenario and high scenario. And we use totally 26 members as I present in the previous slide. And we use bias correction with the CDXT methods. And also in Vietnam, we in the climate change scenario and serial rise, we combine in when the Monterey publics, not pure climate change projection. And here for something new ISCO, we are compared to version 2020 and version 16. And we have some, you can, I would like to highlight here 10 calculation, 10 simulation from CORDEX data. Also one new point in the 2020. And we provide more the drought scenario and monsoon scenario for Vietnam, and some more detail for 16 provinces and also the Trường Sa and Hoàng Sa Islands. And here very briefly the climate change for scenario for Vietnam. The above is for observed change, and the below is for climate projection. You can see that's in about, yes, for temperature in the past, it from the 1958 to 2018, the increase for 0.99 degrees Celsius for whole country of Vietnam, and but only periods from the 1986 to 2018 increased by 0.74 degrees Celsius, and precipitation also decreasing in the north and rising in the south and some other extreme, for example, temperature and hot increase, and the number of cold days decrease, and number of strong typhoon increase. But for the future, so almost both scenario also show the temperature increase in the north faster than in the south of Vietnam. For precipitation for almost increase both rainy season and dry season, also annual precipitation, and other extreme also show the increasing trend. For example, drought, rainfall, and number of strong and super typhoon in the future will increase. And also this, I would like to ignore about the sea level rise because of limitation of time. And here for some sea level in direction map, if sea level rise increase 1 meter in the Red River Delta, with the load around 30%, and in the Mekong Delta in Vietnam 47, it means half of the Mekong River Delta with under the sea level, and for Ho Chi Minh City about 15% with the thing in the sea level. And here for our plan for climate change scenario for Vietnam 2025, we also by the law on the meteorology and hydrology of Vietnam, the national climate change scenario must be updated every 5 years, and and apply and integrate to the every ministry and social economic factor field. And in the next one, we also beyond the CMIPSIC reports, and hopefully we this year we yes, our expectation, we hopefully to use a new one, and we also both use statistical and dynamical downscaling and approach, and we hopefully for spatial resolution and for nationwide we are around 20 kilometers, but we will focus for regional at 10, for example, Mekong or Red River Delta or Central Coast of Vietnam, and also provide the urban scenario and so on. And for projection, we maybe ensemble projection or maybe probabilistic projection. It depends on the how much data source we have. And here we also do maybe we also report on the global warming level 1.5, 2, and 3, 4 degrees Celsius for Vietnam and region. And for detailed impact assessment, we also do the ambition to provide for the water resource, land use, land cover, urban agriculture and food security, also the public health or green energy. Yeah. So and we also want to build the very detailed user guide, like the IPCC athlete interact, or maybe the World Bank web portal for climate change over the world. Yeah. And here we are hopefully together to collaboration with CORDEX. Yeah, hopefully we in the next one we could fully get the data from the CORDEX to contribute to the new one for Vietnam, and also the and also Cicero and Met Office, and especially from the domestic from Vietnamese side, we would like to enhance cooperate with USCS from the Professor Tang and HUS, VNU, Professor Tan, together with the statistical downscaling and dynamical downscaling the outputs for the next ones. Yeah, yeah, this, yeah, yes. This, thank you for your listening. Yeah.
Thank you. Any question for Dr. Kien?
Ken,
Yeah.
thank you for your overview presentation. It's not a question, but I just want to say congratulate, because I think Vietnam IMHAN is the most active institution when it comes to engaging CORDEX. I think you have the right strategy there, which you use CORDEX data
Yeah.
in addition to your own initiative. And also, I would say, this is a very important as far as CORDEX is concerned, because whatever we do, right into the institution like IMHAN, and very much relevant to the society, the societal needs.
Okay, thank you, Professor.
Thank you. Any other question? Okay, in that case, we move to another presentation. Thank you, Dr. Kim. Thank you. May we have, because Dr. Pakon gave me a phone call yesterday that he cannot come today, but however, we have another representative from GISDA, Dr. Polomet. He will give the idea about the needs for regional climate change information on adaptive agriculture in Thailand. Please.
Good afternoon, everyone. I am Pramet Kamisi from Geoinformatics and Space Technology Development Agency on GISTA. And today on behalf of Dr. Pakon Petpayun, because he have a meeting, busy, some meeting which the government agency, another part of the water. I'm not sure about this one. And today I would like to talk about the need for regional climate change information on adaptive agriculture. The mission of the GISDA organization, we focus on about the satellite image data and adaptation about satellite image data for application which about the public health, about water and etc. And one important in all of Thailand is about agriculture. We separate about the agriculture from satellite for agriculture, but we separate in the three parts to study in my agency. The first one on the ground, we is include about the crop area, crop status, crop health, crop damage. Focus on the flood and drought, and the last one is the biomass. We get the data from the satellite and analysis about the satellite image data and provide to the government agency. For example, about we monitoring about the situation of economic crop cultivation. This data is the update every 2 weeks, and we correct about the crop cultivation about the economic crop cultivation, such as about the rice, maize, sugarcane, cassava, and overlay map to the website and represent which government agency in every year. Another one is the flood situation. When we get about the data from the satellite, we analyze the satellite image data to find about the flood area and flood situation over last 10 years ago and to the present. And and combination with the agriculture area to find about the damage from the flood situation over the crop area to support the government agency to the water management. And another one, when we saw about the flood situation area, we get about some analysis from the optical band and the band of satellite data to analysis about the drought index, about data from individual from the Sentinel-2 and LST from the MODIS, and DRI is a new drought index from the satellite analysis data from GISTA, and provide about this on this website to the crop management to government agency. And when we get about the flood situation, drought situation, and the economic crop area in the Thailand, we build about the application for the assessment of plant damage from the natural disaster to assessment about area crop area of the farmer when the natural disaster active to the farmer. And this project is ongoing in progress on the team in the research team to the assessment of the biomass from the agriculture area to find about we use about the satellite data and compare with about the UAV drone to find the biomass over the agriculture area. And another one we find to focus on about the monitoring about the crop health. We analyze it from about the data from the Sentinel and the Landsat combination, and which another band from another satellite, and we find about the normal situation or the positive situation and negative situation over the crop situation to see about the crop health. And the result is we can monitoring about the crop health and warning about the crop stage. And it is about ground about the data from the ground of the satellite for the agriculture. And another one is we focus on the weather and climate from the meteorological satellites. We can about the study on about the crop use, crop water use, and crop pests, crop disease, and the last one is a crop calendar. On the crop use, we get the data from the satellites. We find about the crop area, growth stage, and crop health from the satellite data analysis, and we combination with about the satellite, the parameter from the meteorological satellites, such as about T maximum, sunshine, relative humidity, and go to about the fit about from the model, from the statistical model or mathematical model to see about the crop yield prediction over the Thailand. Another project is in process is not. I think the expectation is, I think in the next year we can get about the UR transpiration from the satellite data over the agriculture area. And another one is the crop pest crop disease from the satellite. We get about the data from the satellite about the weather parameter, and make a condition from about the light age, temperature, relative humidity, rainfall, for warning about the crop pest and crop disease over the agriculture area. And the last one is we monitoring about greenhouse gas, about carbon dioxide and the methane. We monitoring about the CO2 from the satellite because and methane over the global and Southeast Asia because some to the observation which the model in the future to the monitoring over the agriculture area. And the needs of the satellite and climate change to the adaptation in agriculture. In this project is ongoing in this year or the next year. We want to create about the actionable intelligent policy, or we call it IAP, about the climate change and agriculture platform. And the left-hand side is the data from the analysis to use which about agriculture, and the right-hand side is the climate change. We want to combine about the two parts to the support about actionable intelligent policy. This policy is the support about the projection about yield prediction based on climate change scenario, and can be warning about the disaster and slow onset event. And the last one, we can have big data about the combination between the satellite climate model and high resolution, and we can about the show on the high resolution map and the crop adaptation to the dashboard. Okay, thank you very much.
Thank you, Dr. Pramet, for the overview of GISTA. Any comment or question? Yes, Julie.
Thank you so much for the very nice presentation. I'm just curious about how, so from getting the satellite information, how long or how much time do you need to process the information? Is it almost near real time, or how many months will the available products that you were showing here will be?
It depends on about the satellite. Is the meteorology satellite such as about the Himalaya? Is stay on the stay is I mean about the long it stay on in the sky all time. But such as about Sentinel and the Landsat. The Landsat is take a picture. It's about every 16 days. We can get about the one picture over the Thailand, and the Landsat is about I think about 8 days. Yes.
Yes. So when you get that information, for example, from the Landsat or any data, and then you also do an additional processing, right?
Yes.
And then how long is that?
Is that okay? I mean, it's about I think about in the process which the researcher team about one month. Yeah, it's not up to date about. Okay, you want to check again with the researcher team again. Okay, but how long?
Thank you.
Just to help him. Currently they're producing weekly data for 4 major crops in Thailand. So take about 2 or 3 days. Thank you. Thank you.
Thank you. Actually, we have a meeting with GISTA, but I missed that meeting, and they request to use our CORDEX dataset for the project too. So any other question? So thank you, Dr. Pramet. Thank you. I think because the limit of time and we just have our lunch, so I think we can continue with the last session. So we don't have to have break, and we have to break after we finish all the presentation. Is that okay? Okay, thank you. We proceed with the next presentation.
Yes, sorry, we delay our coffee break into after the session completed. So let's go into the next speaker, which is Dr. Noriko Izizaki from Japan, presenting virtually.
I cannot share the screen. Please close that. Yes, thank you.
Yeah, okay, so you have 15 minutes. We kind of very tight on time, so please.
Okay. Okay, can you hear me?
Yes, yes, we can
Thank
hear
you.
you loud and clear.
Yes, thank you. Thank you for giving me the opportunity to present here. Today, I'd like to talk about application of bias correction for the impact assessment in Japan and the role of AP-PRAT. I'm Noriko Shizaki. I'm working in the CCCA. CCCA Center for Climate Change Adaptation in Japan in the National Institute for Environment Studies. Now I'm working with Dr. Sasaki. First of all, I will introduce the climate change-related arrangement and associated organizational structures in Japan. In Japan, Climate Change Adaptation Act was enforced in 2018. Then, not only the national government, each prefectures and municipalities should formulate local climate change adaptation plans. Because, unlike mitigation, adaptation measures may change region to region. But in most cases, the person in charge in each local government is not expert in climate. So they need some support, and the establishment of framework to facilitate cooperation with research institutes would be required. So in terms of this, CCCA plays a role. So in short, our mission of CCCA is to conduct strategic research on the adaptation measures through observational research and monitoring of climate change impacts, and to provide technical advice to local authorities and regional climate change adaptation centers in Japan and the broader Asia-Pacific region. To fulfill these missions, we are developing the future climate scenarios and platforms. For the climate scenarios, we set the protocols and the limited common scenarios, like EasyMIP framework. One is in that we cannot analyze all projections. We can use many GCMs from CMIP 5 or CMIP 6, but we need to limit the number. So data users do not necessarily need to use this data, but the use of common climate data allows us to enter comparison of impact assessment in various sectors. And we can prioritization of adaptation measures. So current common climate scenario consists of dynamical downscaling dataset and statistical downscaling dataset. Since the user needs is very high, up to 1 kilometer, so the spatial resolution of dynamical downscaling data is 2 kilometers, so NHM sim 02, and statistical data is 1 kilometer. So you may think, why not only dynamical downscaling data? So there is a large uncertainty in global models. Then statistical methods are also used to compensate the role of dynamical downscaling data. And this climate data and associated information can be accessible through the web-based platform. But this data set is for only in Japan. But not only in Japan, the regional climate modeling system have also been applied to several countries in Southeast Asia. This figure shows the areas already calculated by regional climate models, NHRCM, supported by Meteorological Research Institute, MRI. Maybe some of you have been involved in the calculation. And thanks to the effort of Sasaki-san, Dr. Sasaki, and researcher in MRI, many high-resolution simulated data sets are now available. So the results are very useful for understanding climate change in each region. And furthermore, it can be used for impact analysis in various sectors, but which have not been effectively utilized so far. In order to share the climate scenarios and associated information, CCCA also hosts AP-Plot. In 2019, the AP-Plot launching ceremony was held by Ministry of Environment in Japan during the G20 ministerial meeting on energy transition and global environment for sustainable growth. So now you can access the, you can use the AP-Plot. So what is AP-Plot? Yes, AP-Plot is a web-based information platform on climate change adaptation in Asia-Pacific region. So the goal is to contribute to the sustainability and resilience of the Asia-Pacific region by informing the decisions and supporting adaptation actions. So it includes several contents, and you can use the Climate Viewer, Climate Impact Viewer, maps, and so on. So please access it once. This is the web address. And any comments are welcome. But however, the current climate projection in AP-Plot and impact information were based on global models only. Thus, we are now planning to employ bias correction on these dynamical downscaling data, and the data will be made freely available for download from AP-Plot. In applying bias correction, selection of observation dataset is important issue. And there is an uncertainty even in the observation dataset. So,
sorry, Dr. Izaki, you have about
yes?
5 minutes to go.
Okay, thank you. For presentation, we are now going to employ bias correction using two datasets, Aphrodite and CHIRPS. Finally, I'd like to introduce the recent initiatives of development of empirical statistical downscaling method. So far, our focus is on the reduction of bias so that the climate scenario can be used for impact assessment. But so the attempt to develop empirical statistical downscaling methods in CCCA are in early phase. One of the recent activity is application of the super resolution technique based on the artificial intelligence. Another is the analog method. In this method, the similar spatial pattern was generally detected from the historical database. And let me share our results using analog method. This figure indicates the precipitation amount during the winter season in Japan. Along the Japan Sea, much rain and snow was observed due to the cold winter monsoon blowing over the warm ocean of the Japan Sea. And there is a series of high mountain ranges separating the Pacific Ocean side from the Japan Sea side. So in contrast to the Japan Sea side, dry and pleasant weather is usually prevailing over the Pacific Ocean side. Under such climate conditions are unique relationships between the correlation of the time series and the geographical distances. Oh, the earthquake, very good, very big earthquake. So I'm sorry. Yes, this figure shows the probabilistic density functions for daily precipitation, indicating the correlation of the time series in the vertical axis and against their geographical distances in the horizontal axis. Maybe you can imagine the temporal variation of precipitation at two stations would generally similar if the geographical distance is small. However, as you can see, there are many station pairs which have low correlations even with the small distances.
You have 2 minutes, Dr. Izaki.
Okay. I'm sorry. Yes, but yeah, this structure cannot be represented in the bias correction, but the analog method can detect the successfully detect these characteristics. Yes, it indicates analog method would be an appropriate method to generate climate scenarios. So today I'm glad to see several interesting studies on empirical studies. So if possible, we hope to share information and collaboration on statistical method in CORDEX Southeast Asia. And it will also provide important insight into the efficient operation of the high-resolution dynamical downscaling. Thank you very much.
Thank you, Dr. Izaki. Maybe we have time for one question, if any.
Sorry.
No? Okay. Thank you so much, Dr.
Thank you very much.
Izaki. So let us invite the next speaker. I think Dr. Sri. So you have about 12 minutes speaking, and maybe if we have a question, and then 3 minutes. Yeah.
You let the next speaker in, I'll join the next one, just not to waste time.
Okay, in that case, we call Miss Jessica Datul Bersila.
I'm really very sorry.
Is it okay?
Yeah, got it.
Huh?
Yeah. Yes, ready. Because we have only a few minutes, let me quickly run through this. And you all know about the location of Singapore. So in an urban context, it makes more sense to dynamically downscale the information. On a regional scale, of course, we do at coarser resolutions. And for Singapore as a country, we need high resolutions. And therefore, what I'm going to speak about is our collaboration with the National Environment Agency, with whom we are delivering the National Climate Change Projections. This study is usually taken up every 5 to 6 years, so we are delivering high-resolution climate projections for Singapore under a matrix of GCMs and a CMIP6 to be downscaled. The progress is still, we are still doing it, so we should be able to deliver everything by next year. But the objective of this exercise initially for about a year or so is to evaluate how well the models perform at high resolutions. So our target is 2 kilometers over Singapore. So what you see here are two domains. One is the 8 kilometers. This is almost like the CORDEX domain. And then we have 2 kilometers over this region. And Singapore is not here. Singapore is actually a red dot, literally a red dot, just at the tip of Malay Peninsula. So, which means that 2 kilometers is essential, or even higher. But just because of the physical feasibility of not going higher than 2, we don't do it. Although we have been testing 400-meter resolutions for Singapore. But we do not envisage doing any climate projections at that resolution. And of course, it's a challenge to do that at 400 meters. So for the 2 kilometers, quite important to see how do we get rainfall. Rainfall is quite sensitive, not everywhere, including, of course, Singapore, is because such a small island as we are, we have a strong microclimate. In the sense that if you look at this, this is Changi Airport for those who have visited Singapore. This is the eastern part of Singapore, and this is the western northwest. And you see there's a clear gradient in the east-west rainfall, which is about 1,500 millimeters. So the east is generally dry, and the west and north are usually wet. So can we have a model, an urban scale model, which can reproduce this kind of observed characteristics? It's not only just this annual climatology, but even a suite of other rain characteristics. So let me show you how it turns out. So this is the WRF model, the weather research and forecasting model, which we run at 2 kilometers, and you can see how the model gets the gradient and even the rainfall. Of course, there's some interpolation here, but nevertheless, it's important to know whether the model can at least resolve the basic characteristics of observed rainfall, and it does. We do bias corrections, and several of you have spoken about bias corrections, but one of the immediate tests is for 2 kilometers, can we get the annual cycle of rainfall as observed in the patients? So what you see here are observations averaged over several points in Singapore, and how does the model perform? Yeah, that's how it gets. So of course, obviously there are biases, but we are not bias correcting at this moment. Now it's more evaluation stage of how well the model can get these characteristics. So generally, we have a northeast monsoon dominated rainfall, which is November, December, and January, and then the rest of the months are dry, although the inter-monsoon seasons do constitute a higher proportion of annual rainfall. Diurnal cycle is critical, so we want to know how the rainfall is distributed within 24 hours in a day, and that's because we have northeast monsoon, the dominant rainfall, and we have southwest monsoon, which is the next higher proportion of rainfall, and this is the averaged diurnal cycle of rainfall. And does the model get it? Yeah, so the model is able to catch that, except that it, of course, it puts the maximum peak, late afternoon peak, about an hour earlier than the observation, but of course it's not a criminal offense at the moment, so we will pass it, and we still have to do some fine-tuning. The spatial climatology of rainfall, you're all very familiar with this, but one thing to highlight here is the observational uncertainty. So this is a big problem here. Even though we have high resolution observations, satellites observations, it's always a big question as to which is the best source of observation we can use for evaluating the models. And this is quite important, is because we do have Aphrodite 25, we have Crew, we have, you all know all the observations, so I don't have to repeat it. But the challenge is that when you simulate at higher resolutions, which means we need an observation of that scale. So if you do a 5-kilometer simulation, which means it's ideal to have a 5-kilometer observations or higher observations, otherwise it doesn't make sense. And the reason is because perhaps the model is good. The model is right, but the observation didn't catch it, the other way around. So we need to really evaluate how well the models do agree. And you can see considerable observational uncertainties between two data sets, the GS map and iMerge, which is a recent product. But anyway, we are concerned only on the land. We will forget the ocean. So on the land, we also have chirps to compare. But of course, we want to know how the model does even on the ocean. So there are some biases. This is on annual scale. Of course, on DJF, there are larger biases on GSMAP. So now we are moving to iMerge more than GSMAP. As and when we know that there are observational uncertainties, we update our observational reference. And JJA, of course, which is the relatively lesser rainfall for the maritime continent, is like this. And we want to, this is most important, is in validating these models. And I believe that's the essence of CORDEX also, is not just delivering projections, just running the projections of future and present, and then you subtract and give the projections, but also to evaluate the models properly so that we have a strong basis of giving the projections. And the point is whether the models can get all these observed features correctly. And one of this is whether the model can get the peak time, maximum time of convection around the Malay Peninsula. If you look at this, yeah, GSMAP and iMerge show this. WRF shows this as well on an annual scale. But if you look at JJA, it doesn't seem to do that. So there's considerable difference in when the model gets the convection right. And you see it's preceding this. It's usually late afternoon peak, about 4 o'clock. But then the model is putting that at about 11 to 12 p.m., which is not correct. So for one season, it looks all right. But of course, we identify that summer monsoon is a problem. Okay, having said that, the next question we ask ourselves is, do we really need 2 kilometers? Because of computational constraints, can we live with a relatively coarser resolution? Because our objective are two-folded. One is the 8 kilometer, the other one is the 2 kilometers. So let's reverse it and see whether the 8 kilometers is any better. Yeah, so this is the annual cycle of rainfall, not bias corrected, rainfall at 8 kilometers. So over the 8 kilometer domain, we choose a Singapore point. And then we draw this annual cycle. So definitely, of course, in some months, it seems it's all right. But then we have to holistically take all the characteristics and evaluate and see whether the 2 kilometers is better. On the diurnal cycle, this is what you saw earlier. So on the diurnal cycle, looks like the 8 kilometer is not good. So sometimes there's a trade-off. For some evaluations, looks like 8 kilometers is okay. For some, it's 2 kilometers is okay. So the question we ask is, if you do have the computational resources as much as you need, then go ahead and do the 2 kilometers, and then you evaluate for which of them is the 2 kilometers really necessary. Then, of course, we add value to extreme high fine resolutions. And this is quite interesting, is this is a diurnal cycle, but annual cycle. So what you have is 4 times a day for the 12 months, and this is the diurnal cycle for each month, but drawn for 12 months in a year. And this is the 8 kilometers, which perfectly fits well, just except the summer months. The 2 kilometer is improving on it, although there's still some summer rainfall issues here. But it is an improvement compared to the 8 kilometers. What is very interesting about Singapore's rainfall is this, that the diurnal cycle is not just important annually, but if you look at the different seasons, we have such a strong microclimate that the diurnal cycle is totally different in different seasons. And this is important for an urban model to really resolve and to see whether the model can reproduce that. And as you see, this is what is a normal JJA and DJF. There's a late afternoon peak, and there's an early peak here, and then March, April, May, and SON. So we did some spectral analysis. I'm not going to talk much about it. It's just, although the point is that when you do the power spectrum, we analyze there are more than one sources of rainfall within a day. So we have a single peak and then a semi-diurnal peak. Extremes is quite important. So does the model get the extremes at that fine resolution? At 8 kilometers, the CDF says so. We zoom in just the top 10 percentile here. But the 2 kilometers is also good enough. Although, yeah, the 2 kilometers does add value here. But if you look at the PDF, where does the model fail? Is in getting the dry spells. The model is good in getting the wet extremes, but it overestimates the dry. So it means that the model rains more than it's necessary. It puts the convection at the wrong time, or it produces more rainfall than it is supposed to. And one more interesting is the land-sea breeze. Can we get it in the model? Yes, we can get it in the model. If you look at the course observations we have, this is the observation, this is the model at 2 kilometers. And you see the diurnal times, so 2, 8, 14, and 20. And you can see how the model gets it. But what's important here is to look at morning 2 o'clock, there's divergence coming out of the island. And at 14, it's 2 p.m. in the afternoon, you can see that the breeze is towards the inland, which we can see from the observation. Of course, we don't have many arrows. It's because it's a coarse resolution. We don't have high resolution data, but the model can get this. And that's why the reason is the models can be right, which we don't know about the observations. We also did some tests on, quickly on the specific humidity from WRF and evaluating them against the radiosondes. And just to say how it is, of course, there are some differences at the middle troposphere to the upper tropospheric levels, but nevertheless, it's not too bad. There's some fine-tuning which we need to do, but the model is able to capture that profiles, vertical profiles. Not bad at all. So the key points here is that we found iMerge to be a good source, so there are considerable uncertainty in observations that we need to quantify before taking the bias and the estimates of the model correctly. The 2 kilometer simulations do add value. Of course, the 8 kilometers at a larger scale, it does. The model still has rooms to fine-tune some parameters so that we can get the summer monsoon rainfall better, but overall, it's a good representation of Singapore's microclimate. And therefore, after evaluating this, no model is perfect, and so it is this WRF at this resolution. But nevertheless, it satisfies about 90% of the characteristics quite well, which means we can now do the downscaling using the GCMs and make some better assessments.
Thank you, Sri. Interesting talk. Maybe we can have one question. Julie?
Thank you for the very nice talk, Dr. Sri. So my question would be, in the WRF simulations that you did, was it at the 2 kilometer resolution? Did you include also urban climate or just WRF only? Okay. And then just comparing this with our some of our simulations also, a 2 kilometer resolution, but not using WRF. We tend to see very high rainfall values that corresponds to high elevation locations. And I'm not sure if this is also true. But for the other locations, I mean, not in Singapore, because you're...
Show me again the annual cycle of comparing 2 in 8, 2 in 8. 2 in 8? Yeah. Back another one. Yeah. Why is it the observation? Yeah. So probably still need some. Yeah. Okay. Okay. All right. But again, maybe this is a fundamental question, Sri. You tune one particular model, which is you think is good and so on. Do you think you need other RCM? Thank you, thank you. Yeah, so let's give a round of applause. So we go quickly to Miss Jessica. I would like to give you like 30 minutes, but unfortunately, we will warn you once we reach into 12 minutes. And,
Good afternoon, everyone. Thank you for inviting me. As I keep saying, I'm not a climate scientist, but I'm here as one who learns with you in the process. And what I'm going to share is really part of an over a decade journey with the climate scientists, and I'll explain it along the way. And this is really a product of over a decade's work with different partners. So as I said, this is our journey on linking science, policy, and practice for over a decade. And for the presentations, this is actually a product of collaboration between scientists, community workers, and those who are in practice. So over the course of the years, you will actually see how we started collaborating with the scientists, particularly that of Manila Observatory, because we wanted to answer the question, why are disasters happening to us in the Philippines, and why is it that so many people lost their lives and assets? And along the way, we met, we tried reading, we heard about IPCC, and we tried very hard to understand, what the documents contained, and that helped us help inform our engagement with the national government, with ASEAN. Actually, we advocated for climate and disaster framework in both ASEAN and APEC. And of course, it led us to our advocacy to 1.5 in Paris. We fought very hard for it, and I think Dr. Tan and Dr. Fred were witnesses to the work that has been done over the years. And of course, for that, we also gained recognition from the UNFCCC Secretariat. So what does your work mean for us? We were told that we cannot adapt based on the global climate models. And so we tried to learn very hard about your downscaled climate information. Long story short, we tried to make sure that the downscaled climate information is mainstreamed in our development planning processes. And this is how we did it in the Philippines. No? In the Philippines, you have international frameworks that are translated into national and then local policies. And then the law says, these are laws that we also advocated for, that we have to mainstream climate and disaster risk assessments in our local development planning processes, in our national to local development planning processes, that will ensure that our pathways for sustainable development are already informed by those climate and disaster risk assessments. Of course, we didn't know how to do it, and that's how the IPCC reports helped us, and that's how the climate scientists helped us. So this is the rationalized planning system of the Philippines. And so the ones at the top are the long-term development plans, mid-term, and down below are your annual investment, annual planning processes. Now, what we learned along the way is that even as we advocated, learning from the climate and disaster risk assessments, it took us to a journey of engaging national decision makers, and then national agency personnel, then local decision makers, and then local disaster risk reduction and management officers. Why the local disaster risk reduction and management officers? Because when the Philippine legislators created the law on climate change, they forgot climate financing. They did not finance the law. So the only law that placed a good financing for work on both incremental and transformational adaptation was the next law on disaster risk reduction and management in the Philippines. And so we ended up putting the burden of climate and disaster resilience to the local disaster risk reduction and management officers. But our law also says that even the frontline villages, and the local governments are our first line of defense. So we had to make sure that they are also capable, because under the law, they would be liable if there were deaths and losses and damages. So let me give the case of Iloilo City. This was already mentioned by by the earlier presentations of Dr. Julie and Emil. Iloilo City is in the middle of the Philippines. It's a very old city, but it's in an alluvial fan, and it has a lot of climate and disaster risk. Okay, so what we did was working with Manila Observatory through the Coastal at Risk project and the work with National Resilience Council. They were able to unpack for us the climate and disaster risk assessments that were understood by local government units. Manila Observatory and the partners refused to be consultants for the local government units. Instead, made sure that when we did the climate and disaster assessments, it was done with the personnel of the local government units so that they understood the maps, and everything in it. And together, they crafted options for risk reduction and adaptation. The final output, I don't know where the clicker, but this is the output from Manila Observatory. What you will see, the comprehensive land use plan is now the long-term plan that actually captures both the risk assessments and the various options for adaptation, mitigation, and risk management. So, Dr. Julie was actually surprised when I said we also use the downscale climate information to actually develop a strategy against COVID. And so you will actually see how we use the downscale climate information up against the COVID that was considered a hazard, and also look at the risk, examining social vulnerabilities, and then ended up with developing a vaccination strategy for Iloilo City with the help of the health experts from Epimetrics. Okay, so, but we have a question. How do we avert losses of lives and assets when the world is heading towards the highway climate hell? No? That's the term of the UN Secretary General. Our solution was to help build capacities for those at the front lines. And so my talk actually revolves around this. No? So this is a competency model that we developed looking at the requirements of the law, the different local memorandum circulars of different agencies, as well as the scientific studies. No? So we developed this in 2021. However, IPCC came up with this, in AR6. No? They presented the risk propeller and the propeller for risk resilience development. And actually, it made us think, was the competency model that we developed enough? No? And so our issue was that those who are most affected cannot wait for most systems to be in place before the next climate hazard strikes. No? So our capacities have to be calibrated against the hazards. And so we redeveloped the model. The outer layer is one that actually looks into requirements and competencies needed if the LDRMO is to help save lives and assets. I'm sorry I don't have the time to unpack this, but I can share the work with you. And I just want to tell you that this is how far we went. From the national level work, we went down to the village level and then enabled the local communities to use your downscale climate data and further assess their own risks. No? And in a way, it validates the points that the scientists are raising. I'm putting on the slides because this one I received a couple of hours ago. The local government of Iloilo City was awarded by the DRM office an award for Beyond Compliant for the work that they do. And because during the past climate extreme events, there's almost zero casualties. and minimize loss of lives and assets. No? So to end, this is my final slide. Our appeal to climate scientists. No? One, we appeal that you characterize no, the current and future climate events. No, help us imagine what your models are saying. Actually, if you present it all, they will not understand it. Help us imagine it. Now, I brought up this picture because of the NAGE recently, and then this local government unit really prepared for it. You know, we tried to imagine how powerful. This was just at the start of that rainfall. They were already prepared. But by the time the height of rainfall came, this will not work. You know, so we need to really imagine, no, help us imagine what those hazards are. For Pag-asa, for example, what does 1.7 mean? What does 3.7 mean, no, for us? And help us understand how the climate will be influenced by the interaction between the historical and climate emissions. And lastly, when you speak of uncertainty, will you also be able to characterize this? No? And that will help local governments prepare for it. So thank you very much.
Thank you, Jessica. You know, I know you for a very long time, and when you're presenting, you're very passionate. You know, so but again, the complexity is there, but the messages is there for us to take. You know, I don't know whether we can do everything or not, but we as scientists will try our best to you know, to serve the community and whatever information that needed, if we can.
Sir, just one message. I just want to tell all the climate scientists, you do not know how many lives you've saved by sharing the information to us. I'm a witness to that. And so in behalf of you know, the communities that we work with, maraming salamat po sa inyong lahat. Thank you very much.
Thank you. So I think in the interest of time, let's move on to the last, but not the least, speaker. I think Dr. Saiful Azmi from Brunei Darussalam. He's online now.
Yes,
Dr.
I'm
Saiful,
here.
salam.
Yeah, salam. I'm here now.
Okay, so
Let
you
me
can share your screen.
Okay, wait a minute. Share. I can't seem to find my files. I put in desktop. So.
What are you looking for?
My files.
Ah.
Is it the organizer already have my files?
No,
before this?
I don't think we have.
Oh, the one I sent it to you last time. Well, because it's when I share screen, it doesn't show.
It's not in your computer.
It's in my computer, but it's in desktop. But it doesn't show my any.
Okay, can you click it from your desktop then?
Okay. Sorry, Prof. Seems to be lost here.
You lost your presentation, so.
No, the presentation is in my desktop, but it doesn't show on my window and application. I don't know why.
Jerson, I don't think we have, right? Yeah.
So sorry about this.
Probably, what about in some folders in your computer, Dr. Azmi?
Okay. Let me look into my email again, if it's there. check. Yeah.
Yeah, okay.
Yeah, but it's still small. But anyway, better than nothing.
Where is this, in the email?
Yeah. This is in my email.
Can you download it?
That's it. That's why I already downloaded it. I put in my desktop, but it doesn't show. It's only giving this. No. Yeah. It's only showing this prop. Make it bigger.
This is Sri here, by the way. Can you give the access to your PC? We'll try to. Yeah.
Oh, okay. I just stopped sharing now. Okay. Should I? What should I do now? See, this is the one I sent to you.
Can you download it?
Yeah, I can download it, but it goes to where? See, this is the thing. See, it's no. Okay, approve. Yeah, I approve it. Yes. So.
Can you give remote access?
I already approved.
You have? Okay. No, it doesn't work.
Yeah.
Can you go to your desktop?
Okay. Can go.
Yeah, you can lower your Outlook and go to your desktop.
Okay. Desktop. This is the one.
Your PC's desktop.
Yeah, yeah. This is the one. Yeah.
Minimize your Outlook. Minimize your Outlook.
Minimize what?
Your Outlook. Your
Oh,
email,
okay,
yeah.
okay. Sorry. Cancel it. Okay.
You can't see your desktop
Oh.
though. Did you?
Now, is it okay now?
I will check. Hold on. Okay, go to your, yeah. Can you scroll?
Yeah.
Okay. Just do as it is. Yeah, it's
Okay,
okay.
Yeah, okay. Maybe
Okay, so-
just scroll, you know.
Okay,
but
no worries.
we are running out of time, Dr. Saipul, so maybe try your best within
Okay,
10
no
minutes
problem.
or so.
Yeah, 5 minutes. It's only the. Thank you, by the way, for the invitation. So, without further ado, so I'm just trying to highlight the regional climate issues and the key strategies. Okay. For Brunei perspective. So these are the summary of my talk. Okay. Talking about the climate models, the climate change issues, and the 10 key strategies, and how Brunei is dealing with the climate change and the climate policy regionally and international, and how Brunei commit to the national determined contributions under the Paris Agreement, and also the food securities and disaster management under climate emergency, these are the some of the key strategies. Okay, the motivation is one of my former master student now. He's working as the meteorological officer in Brunei Darussalam Meteorology Department. Some of the results are being now used for the climate change policy. There is Brunei Climate Change Secretariat in, okay. So I'll show you later. So this the climate model that we used last time for my master student is PRESI 2.0 and under this RCP 4.5 and 8.5. And then the study also we use this CP5 for the IPCC PIP assessment report. This is sometimes in 2016, 2018. Of course, the how do you say this? I was informed by my former student, master student, saying that they're going to undertake the continue this CIMIP 6. So it's undergoing now in process. Okay, so this is the one that was showing you the website for the climate Brunei Darussalam National Climate Change Policy, and then you can actually go to that website. This is sourced from the Brunei Climate Change Secretariat, established in 2020, I think. But of course, it's earlier starting. But so if you look at carefully there, there's a concern about the increase of temperature, 0.35 per decade from the year 1970, and the rainfall per decade as well will be increasing as well. Again, in the past 30 years, in the next 30 years, and Brunei will experience an increase of 0.4 degrees Celsius for the temperature rise, as well as the for the rainfall projections. So the Brunei Darussalam is prone to main key risks, floods as usual in other ASEAN countries as well. Brunei also have issues on floods, forest fires, especially during drought season. So it's very important that we have a climate models to actually identify the dry areas or the hotspots for the center for the disaster team, management team to actually prepare for the worst case scenarios. And the strong wind also is one of the main risks for Brunei, as well as landslides. Okay, these are the climate change, Brunei Darussalam National Climate Change Policy. There are 10 key strategies which they want to adopt. Of course, I don't want to go through. This is so important because Brunei, I just want to highlight, like industrial emission, because Brunei, the main export of Brunei is oil and gas. So that's the important thing, is to reduce overall emissions in the industrial sector, okay, and electric vehicles, to trying to reduce the carbon emissions from vehicles, transport. So currently we have already started EV, electric vehicles charging stations in one or two, I think in one station already in just started actually in Brunei, just last month I think. And all this renewable energy is also very important. We try to go away from oil and gas. Of course, it will take sometimes. So, but in the process of doing that, we also have number 10 to me is important because awareness and educations, as we want to collaborate more with more stakeholders, not only local stakeholders, but also from regional like CORDEX, for example, this.
Dr. Saipul, you have about 5 minutes to go.
Yeah. G2G and so on, university level and so on. Okay. Just want to say about the role of Brunei in climate change within the international politics, how to reduce the carbon emission through Haro Borneo initiative with the countries with the reduced emission by trying not to do the deforestation. And also, we are also dealing with a lot of ASEAN in level. I think Dr. Benny Narita was saying about Brunei commitment in ASEAN seals. So in terms of environmental management, disaster, and the clean energy, we have actually involved in ASEAN. So these are all the adaptation, action that Brunei is doing. And would be doing that in the future, as mentioned by Dr. Narita from the ASEAN Secretariat. So again, Brunei commitment to the national development contributions under the Paris Agreement, trying to reduce the total energy consumption by 63% by 2035, and also other initiative, land transport sector, reducing carbon dioxide emissions, forestry as well, and also Brunei Darussalam also submitted their own NDC. Okay, so this is so important for Brunei. Even though Brunei is a small country, but we take active role in playing these important issues for not only for Brunei, but also for regional. And the important thing now is to try to make it more efficient. Brunei trying to prepare for a lot of things like preparing a worst case scenario. You see, now we are using a lot of technology. Now a lot of people are using the drone to monitor these we call it disaster prone areas. And most important thing as a strategy is to have a faster decision making process and a more effective coordination and management. So in other words, we need to have a more strategic, systematic organization to handle this situation, and we cannot be alone as well. We need to work with others as well, local stakeholders like Disaster Management Center, work with the other ministries in Brunei, and collaborate with also regional ASEAN level, because they learn from each other, how to tackle the issues. So we also need cooperation. The most important cooperation, as I said, collaboration with the ASEAN group and ASEAN level, even in international level.
You
That's
have
all I want
2 minutes.
to say.
2 minutes.
Already done. Thank you.
Okay. All right. That's good. So maybe one quick comment or question, if any. No? Otherwise, let's give a round of applause to Dr. Saiful.
Okay, thank you.
The first time we've been able to engage representative from Brunei in our workshop or meetings. So thank you, Dr. Saiful. Please stay on. So
you're most welcome. Sorry about the problem just now.
It's okay. It's okay. I know it's sometimes it can be a challenge when you presenting remotely. So
yes,
we have to leave before 5 o'clock here. So I'm going to be using, let's say, 20 minutes for the last session, which is discussion, Dr. Jason. So I have some slides to show. Can you help me, Nick? right. So last 20 minutes or so, supposed to be like an hour discussion, but unfortunately we don't have much time. So I think it's quite important for us to get some key messages out of the 2 days workshop that we have. This is quite important for us to chart our, what is actually the next priority when it comes to CORDEX in the next 5 years or so, or maybe 10 years, I don't know. We, of course, under whatever we do, basically we are guided by this so-called strategic plan of the WCRP, because CORDEX basically under the WCRP, and Dr. Aaron has mentioned this in his talk yesterday. In fact, when it comes to the scientific objective of the WCRP, as you can see here, this is relevant to you know, CORDEX long-term response. What CORDEX is doing, long-term response of the climate system, as well as bridging that into the society. So, so yesterday you heard of this under the new plan of WCRP, the so-called Regional Information for Society, or RIPS co-project, basically. So, in this, under this project, there are 4 focuses, but number 2 here is not so much of, in fact, not part of CORDEX. So, the focuses that are relevant to CORDEX is number 1, number 3, and also number 4. And not very clear, but CORDEX is not really under RIPS, but it is said the pillar, you know, one of the strong pillar of this Regional Information for Society co-project of WCRP. You know, so when we're talking about regional information for society, in fact, we have been talking about this even before this kind of plan. You know, when we launched our data center last time, we already have this kind of thinking in our mind, actually, what we are trying to do to serve the needs of the society by providing this product, as well as engaging the institution, you know, like IMHAN presentation, which directly using CORDEX product, I know. So, but CORDEX itself has some of the key scientific challenges here. For example, mega cities, wind, inland waters, you know, regional sea, even regional sea is mentioned, you know, so, and some other you know, challenges, scientific challenges can be tackled within CORDEX, you know. But doing so, there are other things, you know, like capacity building, perhaps going into couple models, convective permitting scale, you know, and also engaging the VIA communities in others, basically, including ESD, you know. So for a decade, you know, we're moving from the beginning of when we discovered, you know, CORDEX. So we, to some extent, we have done something significant, you know, which we have not been able to do in this region previously. Downscaling, you know, CMIP6, CMIP5, GCM, you know, and enhance our scientific understanding, capacity building, and build up the data center, and serve some countries, you know, and also VIA community, as well as used by the IPCC. And we continue doing this at, you know, further downscaling to 5 kilometers, and perhaps soon we will be making this available to the community through this success. We have not been able to do it yet, but perhaps very soon we will be able to do this. But the question for us is the next 10 years, and the next 5 years or so, and of course we have already made the decision. In fact, work has been started for 25 kilometer CMIP6 downscaling over the same region, over CORDEX, and as well as hopefully there will be a coordination of the ESD activities as well, the empirical statistical downscaling. But we are already talking about perhaps we're not just doing the usual thing that we do, which is downscaling, but going into much higher resolution and address things like a multi-hazard assessment and providing information for disaster risk reduction in mega city, because some of the group becoming more, the capability is enhanced. For example, Vietnamese groups and Dr. Duan's group, and even Sri, of course, talking about very high resolution. So, so that could be phase 3, phase 4, but again, in propelling us forward, it would be useful for us to take input from a discussion like this. There may be something that we miss. There could be something that we need to address. So limited time, but I don't know if anyone would like to say something in this very short time. We will welcome. So I have 15 minutes, maybe 5 minutes for your closing. So anyone want to start? Professor Edwin?
Yeah, I think some of the issue that we must go regional and sectoral. And the sectoral issue that are important here instead of hazard is health issue and agriculture. So people need food, need water, and need energy. So maybe after that we can go to energy, because I saw some presentation about energy. So first one is multi-hazard, and then we move to health issue, and then food security.
So focusing on some important sectors and try to serve these sectors. Thank you for that input. Anyone else? Anyone else?
The urban CPM resolution modeling. So if there's anything that we can be involved, we can sort of help with the urban, the one you have mentioned. Yeah, CPM scales. That's something which, because he's doing it, we are doing it.
The thinking is already there, because in fact that title we identified in our first meeting on Monday, and also even tomorrow we still have a continuation of discussion of this. Yeah, tomorrow morning we'll have discussion on it. But the thinking is already, because there are a couple of keywords there: mega city, disaster risk reduction. It's all within the interest of CORDEX, as well as interest of the societal interest in this region, because we're talking about many mega city here in Southeast Asia. Bangkok, of course, Hanoi or Ho Chi Minh City or Jakarta, Manila, and of course Kuala Lumpur. So, but if you put a time scale of 10 years, I think we should also be addressing not just the atmospheric component, but the coastal ocean as well. There are many, issues related to coastal ocean that we have not been able to address within CORDEX so far. So perhaps going into the regional couple model, Dr. Tan is already working on this. In a year or two, perhaps we will be perfecting that kind of model, and we can use that one to downscale, and we can get two products, not just atmospheric product, but as well as for the ocean, then to provide the sea surface temperature, salinity, perhaps sea level rise, and others. So that those products can be coupled with some, I don't know, impact models within the coastal ocean. Anyone? Yes. We need from the stakeholders.
Thank you very much for. First of all, thank you very much for everyone, and also for invitation. I'm Lydia Vitanova from Nikkei Seikei Research Institute from Japan, and I already have experience in climate and a regional model. So regarding to this question, actually this is very important, this question in the right part. So I think it's very important more interaction. I think that group a lot of work they did for the data, for the, to introduce, but it's very important for the users and for the stakeholders that they would like to interact with such a kind of data. For example, in our institute, we're trying to make some innovation co-creation laboratory that we already developed some platform that interact with energy, with building, multi-comprehensive platform, and we would like to introduce such a data for using, also for developing, and also for educational and management purpose. So I think this is very important to everybody to think how could be improved, how could be solved, and how could be made the bridge between the researcher, the data providing, and also about users. So this is my, how to say, talk.
That is very important indeed. I think when it comes to data dissemination, within CORDEX, we still need to improve. There always been a complaint regarding how difficult is it to get data from the ESGF. So usually the ESGF is not the level of for modelers, it's not much of a problem. But for other users, this can be a problem. And maybe we hear from Sazwan. Sazwan has always said that that need to be improved. Who is first? You are okay.
So let me give some view from your next phase. Speaking from the user or stakeholder point of view. So the first thing I think maybe I agree that the missing component is the ocean, coastal ocean. There are still missing of the data for the user to use. The second one is that it is possible to include some the climate information platform, two level. The first one is the regional one, and the second one is at the national, and you can link this platform together. That I think this is very important. The third one is you can put something like interface with the policy maker in this the phase. Probably can make more links with the scientists and the user and stakeholder. So I think that is maybe I speak from the user and stakeholder point of view. Thank you.
Thank you. I think that can be a very useful input. Whether we can do within CORDEX or not, still we need to think. Sajwan, you want to say something?
Actually, I've already expressed my request in the slides, but Prof, maybe we can produce actually maybe one simulation that contain hourly output, especially for the hydrological research group.
Well, you also mentioned about hourly, but I think earlier you mentioned about, for example, in success, it should be made easier in terms of data access, so that's something perhaps within CORDEX we can maybe think about it.
I don't know if this is acceptable for the climate scientists here, but I felt that some of the presentations were a bit hanging for me as a practitioner. So for example, will it be possible for the researchers to have a section in the final, after your summary of findings, what are the implications for policy and practice? So for example, if you're dealing with hydrology, or there was an interesting research about drought and forests earlier, and you have studies on squalls. What would be the implications for practice? I don't know if that's an acceptable part, and it makes your research an action research also. Thank you.
Thank you, Jessica. I think that's a good suggestion, a reminder to all of us as scientists here that when we have slide, maybe we need to have a key messages that relevant to the policymakers. Maybe in workshop like this, where we have a broader spectrum actually from people like you into a hardcore scientist. So so we have to aware of this. So maybe Dr. Veni, do you have any comment from the ASEAN perspective? I know you had a very good presentation, but if you have one or two words, before closing.
Thank you, Prof. I think I pretty much agree with more interactions and collaboration with stakeholders. So maybe combining some inputs here, maybe if there's like a summary with more general languages that's more understandable to common people like me, for example. And then we can circulate the summary, and then we can also have like a workshop either online or face-to-face, not only in my division, but also disaster, food, etc. The second thing, if you have a really good idea, maybe you can consider to write a proposal to ASEAN, and maybe we can link you up with some possible dialogue partners that are interested. Thank you.
Thank you. We will. In fact, I think we will bring this into the discussion within the group tomorrow, and how to, we think that, whatever we do within CORDEX serve the interests of countries within the region. The example of this, what has been carried out by Vietnam, and also that's one thing. The other thing, for example, even Brunei basically has not been using CORDEX, but in the future this may be the case, so. Through perhaps engagement with ASEAN, if there is a room, and then perhaps we can facilitate this kind of thing, because we share common goals. Basically, we share common objective and common goals in terms of addressing climate change. Yes. Luckily, I still have the energy here.
Thank you. By the way, this is my first time to learn about CORDEX. So I'm actually from the International Center for Tropical Agriculture. I was invited by the Manila Observatory. And I think with regards to the question, can we get inputs from various groups or perspective? So it is really important also to have linkages with international organizations like us, because for 2023 we actually have it's called CGIAR1 initiative, wherein we are going to study the vulnerability of the Asian megadeltas, and we're planning to use the CMIP6, and I was happy to learn about CORDEX. Maybe we can explore to use CORDEX in the vulnerability assessment of the Asian megadeltas.
Totally agree that interconnectivity among various groups, NGOs. I believe you're talking about NGOs here, right? You're from the NGOs. So as I said, most of us share common goals, and CORDEX may have something like this, but if we are not connected to those groups, maybe we are less relevant. So we can be more relevant if we are better connected. Thank you so much. How much time we have? I think almost finished, no? Maybe one more comment. Anyone? Okay.
After listening to some of the comments, so this is my thought. Not within the next 10 years, but maybe in the near future, do you think it's useful if we come up with some kind of guidelines on how to use the CORDEX data? Because at this point of time, my feeling is that we, it's just like we set up the data in the ESGF and a success, so, when people ask for data, go there. So there's no such documents that actually guide potential users. First, how to get the data, and then after that, once you get the data, what needs to be done. So what sort of indexes you need to calculate.
That's a good suggestion. Okay.
Okay, I would like to suggest, Prof, maybe we can discuss with the ASEAN Secretariat to develop an initiative about the grid computing facilities in Asian countries, so that we can share later the grid computing facilities to perform maybe the next phase 3 or 4, right?
Yeah, I'm hoping we can come up something, really, that can create impact, and then give this to ASEAN, and then maybe a follow-up meeting or whatever with ASEAN Secretariat. Okay, maybe in the last few minutes, if we have any input from online audience, anyone else there? Anyone from still with us online? Dr. Saiful, are you still around?
Yes, I'm still around.
You want to say anything?
Yes, it's a very good idea for us to engage with CORDEX. Looking forward. So you want any comment in terms of collaborations? I mean, we would like to actually have some experts maybe to train, because in our group we only is very small group. I mean, in a sense that when I look into all of the colleagues' work here in CORDEX, I saw a lot of team, group. Compared to us, we are very small.
Sure. That's but again, I think Dr. Banita earlier mentioned that Brunei has a role in playing some, I don't know, program for the ASEAN climate change. So perhaps a discussion with Brunei, CORDEX, and whatever Brunei Authority in fulfilling the ASEAN needs. Perhaps something that we can explore as well.
Yeah, and also just to let you know, Prof, that we have a secretariat now, Brunei Climate Change Secretariat. They're playing active role in anything about climate. These groups championing this any climate change agenda, whatever issues. The Brunei Climate Change Secretariat.
All right, thank you, Dr. Saiful. I think I ran out of time. I'm going to give the last 5 minutes to Jerson. Maybe Jerson, final word from you. Final word from you, and if possible, maybe Dr. Jarutat also come here. Yeah. So it has been a very fruitful, workshop, 2 days workshop for us. We learned quite a lot of things. What we have done for the last 10 years or so, and there's still so many things that need to be done, unfortunately. And so, Dr. Jerson, can you say a few words? And before you say a few words, let's give a round of applause to Dr. Jerson, Dr. Jarutat, Nick, and I forgot her name. Ken, yeah. So they have been very, working very hard to ensure everything goes well. In fact, everything is well. So thank you so much. So last word from you.
Thank you, Prof. It won't be long because we have 2 long days. I think everyone really tired, and so I would like to thank you all. You fly all the way from your home country to Bangkok, and it's a long time that we haven't seen each other, and I'm really happy. The secret family of CORDEX is a kind of like a family, and every time we we come together. We feel that we are really happy, and because I think we open our heart together. So I think I'd like to thank my team member, Dr. Chalutat, the director of IUCOR. She is the one who managed all flight booking, accommodation, per diem, and transportation for you all. So thank you. And Nick or Lachanan, he's the one who managed all the documents. And the Zoom or the computer system. Dr. Walanyu and Dr. Damlonglit, they are quite efficient in preparing all the plot and the result for us to present here. And Songsak and Keng. Songsak, he does not appear today. They are the one who prepare the logistics for all of you. And there are other people that not appear today, so I thank you them all. Look, please have a safe journey home, and I would like to see you in the near future. Thank you very much.
I think coffee break, isn't it?